Welcome back, everyone. In this video, we are going to go over a few examples of solving quadratics. So we'll take a look at a few quadratics, and I'll kind of talk through the process of going through that flow chart that we went over in our previous video and deciding which method is the best method to use. So let's start off with the quadratic x squared minus 36 equals 0. All right, so in this case, we don't have an x term, so our b value is equal to 0. So what we can do is solve by undoing. So all we have to do is move this 36 to the other side by adding it. And then we can take the square root of both sides. So x equals plus or minus square root of 36, which means that x is plus or minus 6. So our two solutions are positive 6 and negative 6. Okay, so really easy, really simple. It would take a lot longer if we plugged all of these into the quadratic formula, for example. Okay, let's take a look at another example. Let's look at x squared plus 7x plus 12 equals 0. All right, so in this case, we do have a b value, so we can't solve by undoing. We have a leading coefficient of 1 in front here. So what we'll do next is check and see if we can factor this. So we're looking at factors of 12 that add to 7. So we could go through a few different factors. 12 is 6 times 2, but 6 plus 2 equals 8, which is not 7. Two other factors are 3 times 4. 3 plus 4 does equal 7. So 3 and 4 are the two numbers we're looking at. So we could set up our area model. The area model is more useful if we have a leading coefficient. You could set up the area model each time. You could also just write it x plus 3 and x plus 4. We'll end up with 3 and 4 for those two constants. In this case, we'll have 3x, 4x, x squared, and the 12 down here. So rewriting our quadratic, we have x plus 3 times x plus 4 equals 0. And then we can set up the we can set up the zero product property. X plus 3 equals 0, or x plus 4 equals 0. So x is negative 3, or x is negative 4. All right, so we were able to factor this. So we could really quickly just rewrite it in factored form, and then use the zero product property to find our two solutions. So we stopped at, I think that second step on the flowchart we went over. Okay, so next let's take a look at the quadratic 3x squared minus 9x plus 6 equals 0. So here we don't have a leading coefficient of 1. The leading coefficient is 3. So the next thing we want to check and see is if there are any common factors between all of our terms. In this case, a common factor is 3. 3 goes into 3, 9, and 6. So we can rewrite this by factoring out that 3 from all of our terms. We get x squared minus 3x plus 2 equals 0. And then if we divide both sides by 3, we end up with x squared minus 3x plus 2 equals 0. So this quadratic, after we factor and divide, is going to have the same solutions as our original quadratic. Okay, so now we have a leading coefficient of 1, which means we can go ahead and try factoring. So we're looking for factors of 2 that add to negative 3. Two factors of 2 that add to negative 3 are negative 2 and negative 1. Negative 2 and negative 1. Negative 2 plus negative 1 gives us negative 3. Okay, so that means our factored form, we could set up the area model. We could also write out x minus 2 times x minus 1 is the factored form, equals 0. And then we can use our zero product property, x minus 2 equals 0, or x minus 1 equals 0. So in this case, x is 2, or x is 1. Okay, so here we started off with a leading coefficient not equal to 1, but we were able to factor out some common factors, get a leading coefficient of 1, and then we could factor that quadratic, so we factored it really quickly, found our two solutions. Okay, let's take a look at two more examples. For the next one, we're going to be working with x squared plus 16x plus 59 equals 0. Okay, so here we have a leading coefficient of 1. We could check and see if we can factor this quadratic. One thing to notice is 59 is actually a prime number. So the only factors of 59 are, we look at factoring, 59 equals 59 times 1, and also we have negative 59 times negative 1. And neither of these factors add up to 16, our middle term. So in this case, we can't solve by factoring. The next method we want to use, we have a leading coefficient of 1, so we can go ahead and try completing the square. For completing the square, we'll start off by taking our b term, dividing by 2, and squaring. So we have 16 divided by 2 squared, which is 8 squared, which is 64. So 64 is our goal for that constants place. So let's go ahead and add something to both sides. So we end up with 64. We're at 59, so we just need to add 5 to both sides, and then we'll get 64 in that constants place. So x squared plus 16x plus 64 equals 5. All right, now on the left side, we have a perfect square, so we can rewrite this quadratic as x plus 8 squared, and the right side is 5. And then we can finish by solving by undoing. So take the square root of both sides. X plus 8 is plus or minus the square root of 5. 5 is not a perfect square, so we have an irrational number here. We'll just leave it as square root of 5 in our answer. Our last step is to subtract 8 from both sides. And usually when we have a number where we have a rational number and we're adding or subtracting an irrational number, the rational one will be on the left. So you might notice that I'm writing the integer on the left, 8, negative 8, and then putting the square root on the right. So here we have x equals negative 8 plus or minus square root of 5. So in this case, we couldn't factor, but we were able to complete the square by finding our goal and then just adding 5 to both sides and taking square roots. Okay, finally, let's finish up with our quadratic formula. So let's take a look at the quadratic 3x squared plus 9x plus 2 equals 0. Okay, so we could start by checking to see if there are any common factors. We don't have a leading coefficient of 1. So we have 3, 9, and 2. Unfortunately, 3, 9, and 2 don't share any common factors aside from 1, so we can't factor out any common factors. This means that our leading coefficient is not going to be 1. We could try to check factoring, so you could look at factors of 3 times 2 or 6. That add up to 9. Unfortunately, if we try all the factors of 6, none of them are going to add up to 9. So we're not going to be able to factor this quadratic. Our last method is to solve by the quadratic formula. So one note is we could factor out a 3, and we would end up with 2/3 in this case, and then use completing the square. However, 2/3 is going to be a little bit more difficult to work with. We'll be working with some fractions and decimals. So rather than do completing the square, which we could do for any quadratic, let's go ahead and use our quadratic formula in this case. So we'll start off by identifying A, B, and C. A is 3, B is 9, C is 2. Let's take those values and plug them into their spots in the quadratic formula. Negative b, negative 9, plus or minus the square root of 9 squared, b squared, minus 4 times a times c, all over 2 times a. We'll start by simplifying inside of our square root. So we have 81 minus 24 over 6. Then continuing to simplify inside of our square root, 81 minus 24 gives us, I think, 57, right? 81 minus 24. Yep, 57 divided by 6. And then, sorry, we have a plus or minus here. Okay, and then for 57, I think 57 is not a perfect square. So in this class, we're not going to worry about simplifying our square root. We're just going to leave it square root of 57. And we can't really do any more simplifying. So we could split this up and make this term over here 9 divided by 6, so negative 3/2. We could also just leave it as one fraction. So we would end up with, this is our solution, negative 9 plus or minus the square root of 57 over 6. So in this case, we have a leading coefficient that's not 1. We can't take out any common factors, and we can't factor it. So we ended up using our quadratic formula, which was kind of our last resort in this case. As I mentioned earlier in our previous video, we can always use our quadratic formula in completing the square. However, sometimes using quadratic formula completing the square will take a lot longer than our other methods. For example, looking back here, when we solved by factoring, we only had a few steps that we had to take. We just split it up into its factors and then use the zero product property. So we didn't have to worry about divided by 2 squaring or simplifying all the different parts of our quadratic formula. Okay, so in this video, we just went through a few examples of how to choose a method when solving quadratics, because some methods will be faster, more efficient, easier to use than others, depending on the quadratic that we're solving.